Good morning, students. Myself, Arun sir. As we all know, that CBSE has released its board date sheet. So, from today onwards, we'll study chapter one by one, all chapters of mathematics, and plus we'll continue with science. Welcome to my channel, Home Coaching channel. So, from today onwards, I'm beginning with the first chapter of science, that is chemical reaction and equation, and we'll see how we will able to learn this chapter. Okay, so let's begin with, that is chemical equation, or we can say the chapter name is chemical reaction and equation. We will broadly classify and able to learn what is given. That is, two things are there. One is reaction, another one is equation. Here I have written the short form of equation. So it is given reaction and that is equation. So first of all, we must able to distinguish between both of them. What they have given, like they have given is reaction. Reaction means I will write it in the word form. Okay, right? For example, magnesium plus oxygen gives magnesium oxide. What it gives? Magnesium oxide. Now, this is a reaction, and now I will write in different form, that it will be called equation. How? See, magnesium, it's a metal, we know its symbol is Mg. Now I am taking it in solid state, plus oxygen, that is I am taking in gaseous form. So I will get what? Magnesium oxide. Okay, so and that is in the solid form. Now first thing is, we must know what is the reaction. How will we represent it in the form of equation? After that, now after writing this equation, we must balance. The first and the foremost thing is given in this chapter is about the, that is how it is balanced. So we have to write, we have to see here in left hand side that in magnesium we have only one atom, and on the right hand side also we have magnesium one atom. That means it is balanced. But according to the given in this oxygen, they have given in two atoms. So I have to balance it. I have to write here. So to balance magnesium, I have to write this. So now I can say this equation is in balanced form. Okay. One more thing, what they have given in the on the left hand side of the equation, that is called reactants. Here it is given, it is in the form of product. So what we have seen here, it's a reactants, it's a product form. Okay, so this what I have written is called equation, and in the word form I have written, it is in the word form. So we will say that is a chemical reaction. So that is, by an example I can say, we can easily distinguish between both of them, what is chemical reaction and what is chemical equation. So this is clearly here we can see. Okay, or more things we can see here is the, it is also, it's in, we can show in the form of activity also. That is, here what I want to say is, what I want to explain is, there's a magnesium ribbon is burnt in presence of oxygen, but I got magnesium oxide in a white dazzling form. I got the in the solid form. So this is, and from this lots of questions we can easily find, like why magnesium ribbon is cleaned before burning in presence of oxygen. what will happen? If you didn't burn, you if you didn't clean it before burning, what will happen? It will enable to react clearly with oxygen. So we have to clean it, we have to remove the dust particles on the magnesium ribbon before we try to burn it in presence of oxygen. We all know without oxygen you can't burn anything, and if you want to extinguish the fire you want CO2. Okay, so that is what they have given. So this is the basic difference reaction between the reaction and the equation. I hope it's clear. So now we'll go to the next step. The next step is I'll add more reactions here, more equations here, so we able to easily can connect with the what is this chapter is chemical reaction and equation. Okay, so lots of examples we have. So one more example I can we can give, like what you can write here is in the lots of reactions are there. Like for example, if I take the example of zinc, it's a given metal. Okay, it's a metal we have, and when I react with this H2SO4, what is this? It is acid, and that is what we call it sulfuric acid. That is given is sulfuric acid, and now we can see like what will be the product here? Zinc will react with sulfate, ZnSO4 plus you got here hydrogen gas is released. See, what is my motto in writing these equations? I will tell you later. Lot of things you will find here. See, lot of things. For example, now I have taken this in solid form, that is an acid. When I react with here, I got hydrogen gas. Gas is released. Okay, so we can see more examples. Like, let's take an example about gases, like carbon monoxide. You all know highly poisonous gas. Okay, so when I react, I take these two gases. What I will got? What I will got is that is what I got is alcohol. Okay, that is called methanol, and that is in the liquid form. Okay, let's see how we'll able to how this equation occur. See, now first thing is let us balance this equation. Okay, if I see 4, so I can write 2 here, or if I write 2, okay, so now we have oxygen only 1 balance, carbon is 1 hydrogen is 4, the equation is balanced. Okay, what here I am writing is one more thing is that is what, that is at the 340 atmospheric pressure is there, at what we got the product that is called alcohol, methanol. Okay, so lots of reactions are there. Okay, we can mention and easily connect with that. Now, before going to ahead, let us see how they now what I have found is gas is formed. Okay, one thing is that what I found from this reaction, that how we'll say that reaction has happened. So what will write here is gas is formed. Okay, one thing is gas is formed. Another thing we can write, I will show you later, that is how temperature changes. Okay, how temperature changes, and in some reactions we can see color also changes. Color changes. Okay, gas is formed, I can say, or if we go in a technical form, we can write gas is evolved. Okay, so lots of things happens. Gas evolved, temperature changes, color changes, or states also changes. How we can see that, for example, when I mix two gases at this atmospheric pressure, what will happen? I found it liquid. So lots of things I can consider. We have found that what happens when a chemical reaction occurs. So that is how we can identify. Okay, from this, I think hope everything is clear. So now we'll move to the next topic. From this, from my point of view, I got something which is, we can easily understand. So now this is, I am studying chemical, that is reaction, that is chemical changes there. So that's our basic difference, chemical change and physical change. Okay, so two things now in my mind, that is what is, you know physical and chemical change. So these two things are there, so here we can find easy. Okay, there is a chemical change, chemical change and physical change. Before I further go deep in this chapter, let us see, let us learn about what is physical change and chemical change. First thing, what we have seen from these reactions is that they are irreversible. But they are reversible. Okay. And here, from chemical composition, what I found is chemical composition, new product is formed. Okay. And here, what I say, no new product is formed. Well, this change is, I can say, this change is permanent. And this change is temporary. Okay? This change is permanent and this change is temporary. For example, boiling. You can say, see, physical means physical appearance, color, size, shape, their changes like from one state to another. Like if I take ice, I have taken the ice cube. Yeah, well, let's draw this. This is ice cube. If I heat it, its temperature changes and here it forms water. But it is irreversible also. From what I can convert it into ice also. So, like boiling is lots of things are there. So we can say and identify. Okay. So what is a physical change? But this change is permanent. How? If I cook raw vegetables, after cooking they can't be converted into raw form. Okay. So that is why we say this is a permanent change, it's a temporary change, it is reversible, it is reversible. Okay, so here no new product is formed. Here from chemical composition, new product is totally, completely new product is formed. So that is what there is a basic difference. Or more examples we can take. Like for example, let's take more examples about it. Burning of a candle. Burning of candle. Now what? Burning of candle is what? It's both physical and chemical changes. Both. Okay. Here it is physical and chemical, both. How we can say, like melting of wax, that is what physical change. Melting of wax, and that is what now we have a chemical change. Chemical change here is burning of wick. Okay. burning of. Okay, so there are a lot of examples, no, which can know, which can easily explain or describe about the chemical or physical change. Lot of things are there, lot of examples. Okay, so I hope it is clear. Okay, so if you have any queries, you can now message me on my channel so that I can easily clarify your doubts. Okay, let's go further. Okay, now we have seen, I hope this is clear, what is chemical reaction and chemical equation. Okay, now further we will discuss about types of chemical reactions. We will discuss about the types of chemical reactions. So, there are 5 types of chemical reactions. Good. There are 5 types of chemical reactions. But before that, I want to say something. There are a lot of reactions are there, no, which occur in our daily life. For example, we have a reaction of photosynthesis. Okay, we have more reactions: respiration reaction, dusting of iron. See, so there are lot of reactions are there. So we'll study one by one. Okay, we have in earlier classes we have studied how photosynthesis process occur, like plants, how they produce their food, able to produce their food with the help of CO2 plus water. So let it be able to able to represent no equation. Okay, so it will be more able to we can say that it will be more able to clarify. Okay, so let's see what we can no okay, photosynthesis reaction. Photosynthesis reaction. Okay, so photosynthesis reaction is what plants needed: CO2 plus water in presence of sunlight. Okay, in presence of sunlight plus they need chlorophyll, a green pigment which is present in plants. That is why we say that plants are of green color. So now what I needed for the plants, what they needed: CO2 plus water. Now what will be the product? Product will be chlorophyll. Oh, sorry, product will be, what will be in presence of chlorophyll? Sunlight. What I will get is food. That is in the form of glucose, or we can say in the form of carbohydrate. So that is what carbohydrate, or we can say, we can write it's in glucose. Okay, so what I got here is food plus oxygen. What I got? Food plus oxygen. So here what I got is, this reaction is photosynthesis reaction. We actually, this is a very common reaction. Nowadays we are studying till 7th class. In 7th class also, what the plants needed: CO2 they need, plus water in presence of sunlight, plus having a green pigment, chlorophyll. Okay, so what we got is food plus oxygen. So that is, this reaction is called photosynthesis reaction. Okay, now one more thing is, this is a photosynthesis reaction. Now we can write more what we were talking about, the real life equations. So first is photosynthesis reaction, second we are talking about respiration reaction. Breathing, inhaling, exhaling. See about the respiration reaction. Earlier we have seen the photosynthesis reaction. Now we'll have a respiration reaction. What is this? Let us write with the we able to able to represent in the form of equation. Okay, so I hope now we all know that is a basic difference between reaction and the equation. That is what reaction we write in the word form and equation we write in the symbol form. Okay, so now let us write this respiration reaction in the symbol form. So what to do is, let's begin with. Now, what happens? Food. I will not go in deep, but let us. I am able to explain in brief. Okay, this is what food. We all need food. Why we need food? To work. If we get energy from this. Okay. So let's go further. Glucose plus oxygen. What I got is, when the heart pumps blood. If we go a little bit in a deep, when the heart blood pumps. So what happens? Blood takes food plus oxygen, with a high pressure in arteries with a thick walls, and it takes to the veins where it takes to the cells where it is divided further, arteries further divided into capillaries. So there we all cells will get food and oxygen, and in return, in veins, through veins we can say what we get, cells they return CO2. Okay, what I got is CO2 plus water plus that I can here I can identify out with energy is so that's it. And through veins it again the blood, that is deoxygenated blood we say, because it contains CO2 from lungs. CO2 breathes out, and then we can say that the blood then again goes into the heart. That is always a double circulation. So we'll discuss later in that lab process. No need to worry. But still, but here my motto is to explain, to write this equation, reaction, respiration reaction in the form of equation. Okay. So that is what it is. Okay. So photosynthesis reaction is there, respiration reaction is there, lot of reactions are more there. Okay. We can say rusting of iron is there. We'll discuss it later in the corrosion topic. But before that, let's now discuss about the types of reactions. Okay, types of reactions. Okay, so firstly, I can say that is combination reaction. Okay, now I will discuss about the types of reactions. So from this, I am going to explain it. What is given is types of reactions. Okay, types. So first reaction is combination reaction. Okay? What is combination reaction? Combination reaction is simply defines, we can say, from this word, that is combination. Okay, but how I will combine two reactants. Like for example, we can say burning of coal. Burning of coal. So here is C plus O2. What I got? CO2. Okay, plus heat and light is also produced. You can write this also. Okay, but the main product what I got is CO2. So here what I have noticed in this reaction. Okay, I will write more so that you will be able to connect with that. First is burning of coal. Second is formation of water. Okay, second is formation of water. So formation of water, how? We will see two gases here. Ultimately what I got is water. Okay, so that is in the liquid. So we have seen here burning. Okay, I will write in the again I will write burning of coal is there, formation of water is there, So this is what we say is a combination reaction. What will happen? Combination reaction. What I notice here, okay, I'll write one more example, then I will explain this in little bit of detail. Okay, so third one they have given is more example I can take. Uh, Formation of water is there, burning of coal is there. Okay, burning of natural gas. Burning of natural gas. Burning of a natural gas. What's the formula for that? Another name is methane. Okay, we'll discuss about this in carbon chapter. But before that, let us see. This chapter is a basic chapter. Why I'm giving more stress on this chapter? Because this is the chapter is the beginning of chapter. After that you will find lots of reactions in each and every chapter. Okay, acid, base, and salt is there, metal, non-metal is there, carbon chapter you all know. So let's first focus on this chapter. Okay, now what I'm talking about is burning of natural gas. So burning of natural gas is methane plus oxygen. Here what you will got? You will got what? CO2. Okay, what else? You can find water. Plus, if you burn a gas, heat and light will reduce. So you can write also this. Okay. So what I found is in three reactions I have written: burning of coal, formation of water, and burning of natural gas. So more we can write also. Okay, one more. Everybody knows this. What's this? Calcium oxide. Another name is slaked lime. When I react with this, what will happen? CO2, I want this calcium carbonate. Okay, that is what I can got. Okay, so this is slaked lime. Okay, if I I found this, or otherwise I can write more. That is, if I react with water, what will happen? What will happen? What was that is called what I got? Oh, sorry, I have written the that is we say is a quicklime, and that is what it say is slaked. Okay, this is a quicklime and this is a slaked lime. So okay, you can easily connect with this type of reaction combination, that in all these what we have? Two reactants. We have two reactants, and what I am getting is only a single product. That is clearly defines combination reaction. In this, we react with two reactants, two or more reactants, but we got the only final product, that is one. So that is what is about combination reaction. Okay, so we can easily connect with that. So this is called a combination reaction. Now I hope it's clear now. Now we will move to further type of reaction. Further type of reaction, further type is next type, that is called decomposition reaction. Now, so now decomposition reaction. I must rub this. I hope it is clear now. So we'll move to the next type of reaction, that is called decomposition reaction. What is called decomposition reaction? Decomposition reaction. Decomposition reaction. So, a decomposition reaction is when we heat, what I say. Okay, I must write example. decomposition reaction. First example I have written calcium carbonate. Here it is, we can say it is a marble. Okay, marble, chalk. Okay, it's a common name. Now, when we heat this calcium carbonate, I got what? CaO plus CO2. So this is a type of, you can say that it is a decomposition reaction. One more example I can take. What can I take? Lead nitrate. Pb and NO3 whole twice. When I heat this, what I will got is lead oxide plus NO2 plus oxygen. Okay. So that is what I have written. Now I can, if you want to balance, you can balance here. Lead is atom is 1 here also on the right hand side also. Okay, but what happens is about oxygen. First of all, see 2 is there, so I can write 2 nitrogen, but we have oxygen is 6, so we have 6. Okay, so we need to balance also. In this section, I must, I can say, must emphasize more on this, that we need to write a complete reaction and balance also. Because what will happen in the exam, you will find a lot of reactions in the form of word form. First, you have to write in the form of equation, then you need to balance it. So that is how, the trend follows for this chapter, how board exam, gives a questions for this chapter. So that is what we got. Now, from these two reactions, what I find is that only one reactant is there. I am heating it. After that, I got 2 or more than 2 products. That is why this reaction is called decomposition reaction. Okay, we can take more examples also. If I want to take, for example, FeSO4. When you heat it, iron sulfate. When you heat it, iron sulfate. So what will happen? You will find 2 gases. SO2, SO3 plus you got what? Fe2O3, iron oxide. You can balance also. We have 2. Sulfur we have 2. Now oxygen we have 8. So 2 plus 3, 5 plus 2, 7. Okay. So that is what they have given. Or iron oxide is there. So if I write this, or I can, 3 plus 3, 6 plus 2, 8. Oh sorry, it's already balanced now. Okay. What I got is iron. On the left hand side, we have 2 atoms. On the right hand side, we have also 2 atoms of iron. Here I got sulfur of 2 atoms. Here also I balance 1 and 1 plus 1. 2 atoms we have. Plus, now oxygen. We have 8 atoms. Here also I have got 3 plus 3 plus 2, 8 atoms. Okay. So that is how we can write this. So from these 3 examples, what we able to find a basic difference between combination reaction and a decomposition reaction is, in decomposition we heat only one reactant and I got more than 2 or 2 products. But in combination reaction, I combine 2 reactants and 2 or more than 2 reactants. What I got? Only single product. So that is how they have the basic difference. And sometimes board may ask the question why we say that decomposition reaction is the opposite of combination reaction. Okay, so that is the basic reason behind it. Okay, so they have clearly explained also that in combination we have 2 or more reactants to combine to get only single product, but in decomposition only one reactant is there and we find the product 2 or more than 2 products. Okay, so that is a basic difference between this. So here we have studied about 2 reactions, 2 types of reactions. Sorry, combination reaction is there, plus we have decomposition reaction is there. Now we'll move to the third type of reaction. Third type of reaction. Now third type of reaction is displacement reaction. So that is what we have about this chapter, only talking about the reactions, equations, how they form, okay, and what will be their result. So that is what we have to. So lot of things are there, but it's a basic chapter. So we have to clarify on this chapter so that we be able to do further chapters very clearly. For example, now I am taking third type of reaction, that is called displacement reaction. Now, displacement reaction is what? Is why is it? Displacement reaction is when a highly reactive metal reacts with least active metal. What will happen? It will displace it. How? We can see from the example. For example, we have example iron. When an iron nail is dipped in copper sulfate solution. Copper sulfate solution. What I got is FeSO4 plus FeSO4 plus copper. Fe plus CuSO4 plus. Here iron displaces copper sulfate. Yes, and no, it makes product with the sulfate and copper leaves behind. Okay, so that is why here it is an example of color changing also, which I was discussing earlier. So now see, here what is its color is blue, but here color changes. It you can say it loses color. Loses blue color. Okay. So lot of things are there. So we have for okay. We'll take more example. We have taken iron. Okay, we can take zinc also, because zinc is also highly reactive in copper. We'll discuss later about how it reacts or something like which metal is highly reactive, least reactive. We'll discuss later in further chapters. But right now we have zinc plus copper sulfate. I have got zinc sulfate plus copper. Here zinc displaces copper sulfate and displaces copper, because copper is a least reactive in zinc, and it makes compound with sulfate and copper. So a lot of examples are there. You can see also, for example, lead. If I take with cuprous chloride, what will happen? What will happen? You will see here I am able to make reaction with this, and copper leaves behind. So from this type of reaction, we able to connect, we able to find that how highly reactive metals displaces least reactive metals. That is why this reaction is called displacement reaction. That is why this reaction is called displacement reaction. Okay. Okay. More examples we can take, but let's move further. Another type of chemical reaction. That is what it is called double displacement reaction. Double displacement reaction. Double displacement reaction. What will happen? I will explain the example. For example, if I take a basic example, Na2SO4 sodium sulfate plus barium chloride, I got what? Here there exchange of ions. So that is why it is called double displacement reaction. Here sodium makes compound with chlorine. So I will write sodium chloride plus barium sulfate. Now what we got is, here we need to balance also. Okay, so first step is write the reaction. Again then we need to balance it. How? Sodium we have. Okay, now we have both. We have balanced it. Now, but barium we have single one, chlorine we have two, and sulfate is single one, here is also single. So now you can say that I have written the balanced chemical equation. Now, one more thing about this is what? This reaction is also called precipitate reaction. Precipitate reaction. We all know about, snow. We have seen, we say furthermore example about it, snow, hail, mist. So what happens? Why we say this reaction is precipitate reaction? Because in the end we find the precipitate form of barium sulfate left behind in the test tube. So that is why we say, or we can show also how this is what is formed is here is what we say is formed is here, this is barium sulfate is left behind. That is why it is unreactive. So that is why we say this is a double displacement reaction. Okay, I hope it is clear now. Let us move to the last type of reaction. Last type of reaction means oxidation and reduction reaction. Last reaction we are now discussing over this chapter is oxidation and reduction. Here we have discussed two types of reaction. I hope you are able to connect with me, and if you have any queries on my channel, you can comment, like, share, subscribe. You can do anything. If you have any doubts, you can ask me. Okay, because this chapter is very interesting in science. Science is very interesting topic which increases our curiosity. So let's focus more on this chapter. That is, the last type of reaction is oxidation and reduction. Now, oxidation and reduction, both are different. So how we'll able to learn about this is oxidation means to add oxygen. How? When I react copper with oxygen, what I got is, see, adding oxygen to metal, I got oxidized. Metal is oxidized. So here we said this reaction is oxidation. What about reduction? If I take this with hydrogen, what will happen? Copper plus water. You can see here it got oxygen, so we say oxidation. Here I got is reduction. So what we got is, here you can say it loses oxygen, so it's a reduction, and here it got oxygen, so I can say it's an oxidation. So I have given you more, I will give more example later on, but from this reaction what we have seen, both oxidation occurs plus reduction, and that type of reaction in which oxidation and reduction occurs both same time, so we can say this reaction is called redox reaction. In a reaction, if only we lose this oxygen, so say it's a reduction, or if I add hydrogen, so we can say it is a reduction. But if we like how I add oxygen and I got oxidized product, so that is why I say it is an oxidation reaction. But if both oxidation and reduction occur in same reaction, we say it is a redox reaction. Okay, so that is what they have given. So lot of more examples are there. We can see, like we can see ZNO, zinc oxide is here, which is we use carbon in a coke form to reduce this. What I got? Zinc plus zinc. Here it loses oxygen, so it is a reduction. It gains oxygen, it's an oxidation. So a lot of examples are there we can study about, which easily explains about oxidation and reduction. Okay? So this is what we able to learn and connect with the chapter that is given about 5 types of reactions. Now, further we move to next topic is corrosion. What is corrosion? Corrosion, what happens when if you put iron outside. So what will happen? When iron reacts with oxygen plus water, that is when iron comes in contact with oxygen and water, what will happen? You tell. What will happen? You will get very easily, you can say, rusting of iron. I will write in this combine, that is the formula of rust. X is number of water molecules. So iron does not react with water. Iron reacts with steam. Okay. Iron, what happens? Reacts with steam, or I can say in gaseous form I am taking this. So here what you get is Fe3O iron oxide. So we must remember that iron doesn't react with water or oxygen. It reacts with steam or gas. Metal reacts with steam or gas. Here, what I want this. Okay? This is what they have given. Now, you can balance also easily if you want to balance. We will, so here is hydrogen is 2, but oxygen is 4. You can write 4 and 4. That's how we will be able to balance it. Okay. Fe, oxygen, water, this is water. Another we can, when we bring silver coin in our homes during festive season, after 1 year, what happens? They got, what will happen? From air, that is Ag plus H2S. Here is hydrogen sulfide, they react with silver and we got silver sulfide plus hydrogen. AgS. So here is what happens. Silver reacts with hydrogen sulfide from air, and here we got silver sulfide plus H2. Okay. So that is how we find the corrosion in iron, in silver. One more we have in copper also. Okay, what happens when copper, I will write here, when copper reacts with oxygen plus water plus CO2, what I have got is CuCO3 plus CuOH whole twice. We got the greenish layer of copper carbonate plus I found copper hydroxide. Here also we can balance also. It's already, sorry, I have written like this, copper. This is what they give. 2 atoms we have, and with carbon we have 1. Now oxygen we have how much? So we can balance also. We have already balanced that. Oxygen we have 2, hydrogen we have 2 atoms. So how this happens? Corrosion. So that is what about this chapter. One more topic is there. If I explain, that is rancidity. What happens if you put outside the oily packets or related to ghee products? What will happen? They get oxidized. So they get oxidized. We feel like smell of something like for more example, like when we bring the packets of chips, when we open it and we keep it for some time, what will happen? They will and lose the taste of eating it. So lots of things are there. So for this, what we can do is we have lot of things. We can put this in the refrigerator also. Okay. Otherwise, ghee oil products. Further we can add antioxidants to them. Okay. So lot of things are there. We can keep it in the refrigerator to prevent rancidity. or what we can do, first process is refrigerator. Second, we can add antioxidants. Any example? I will give example. BHA and BHT. These two kinds of antioxidants we can add so that we able to avoid them to get oxidized in presence of air. If we add full form of it, you got butyl hydroxyl toluene. Here is butyl hydroxy anisole. Okay, so that is how we are able to protect the ghee oil related products. So this is for today. So that is for today, and I hope you able to connect with me. What I am able to explain the chapter, able to learn the topics which are important for this chapter. Further, you can comment, you can subscribe, you can like my channel, my own coaching channel. Any doubts you have, you can clarify. So we'll meet you in the next video. I will explain further about more reactions we will take further, and we'll discuss more about this. Okay, so thank you for today.